Hello everyone, this is Jahangeer, your maths coach. Now we are going to solve one practice paper for 9709 AS Pure Mathematics 1. So this is a good paper, and if you know how to solve all these questions, then believe me, you will be quite confident to solve questions in the exam paper. So let's get started with this question number 1. That says find the set of values of m for which this line and the curve with the equation intersect at two distinct points. So suppose this is your curve and this is your line intersecting at two distinct points. So we will solve these two curves and then we will apply this result, discriminant greater than 0. So now what we are gonna do, y equals mx plus c, we will substitute over here. Then this y will be mx plus 1 equals 3x square plus 2x plus 4. Now I will shift everything to right side. Then I will get 3x square plus 2x and then mx to right side minus x plus 4 and then 1 right side minus 4 and nothing left side. So that's 0. So now I got 3x square over here. We can combine that. X common, then 2 minus m, and 4 minus 1 is 3. So this is a quadratic equation which we got. And after that, I told you, since it is intersecting at two distinct points, so for any quadratic equation which is giving you more than 1 point or two distinct points, at that time we need to apply d greater than 0. And d is the discriminant, which is b square minus 4ac greater than 0. Now what is ABC? So over here, this is your A. This whole x coefficient is B. And this 3 is C, right? So B square, 2 minus m whole square, minus 4 times A, which is 3, and C, which is also 3, greater than 0. So now I got 2 minus m whole square, and 4 times 3 times 3, that is 36. So I can write 6 square. Now I will use this result. Please try to remember that a square minus b square can be written as a minus b times a plus b. So this is 2 minus m minus 6 times 2 minus m plus 6 greater than 0. Now I got 2 minus 6, which is minus 4, then minus m, and this is 2 plus 6, which is 8, 8 minus n greater than 0. We can take minus common from here, then 4 plus m, then times, we can take again minus common from here, then m minus 8 greater than 0. And then this minus and this minus will combine together and sign will be positive now. So m plus 4 times m minus 8 greater than 0. So when you have this, then you will draw real number line. You will use these results, roots minus m plus 4 equals 0, then m is minus 4, and m minus 8 equals 0, then m is 8. Now m coefficients are positive, so here it is plus, then minus, then plus. And this expression is positive, so we have to cover positive region. So our m should be less than minus 4, or m should be greater than 8. Now we have to check whether is there any condition on m. So find the set of m. No other condition like find the set of positive values of m. It's not written anything. So this will be the answer, either m less than minus 4 or m greater than 8. Now equation of the curve is given to us. It is given that the point 4, 7 lies on the curve. Then find the equation of the curve. So we can write dy equals 3x to the power half minus 3 times x to the power minus half, and then dx I will take to right side and then I will integrate. So dy integration is y, and 3 times x to the power half integration is half plus 1 over half plus 1 minus 3 times x to the power minus half plus 1 minus half plus 1 plus c. So y equals, now when you combine this, 3 over 1 over 2 plus 1, so this is 3 over 2, so that will be 2. You can use calculator. And x to the power 3 by 2, and here minus 3 over minus 1 over 2 plus 1, which is 1 over 2, so this is minus 6, and x to the power 1 over 2 and plus c. Okay, so we got that. Now this is our equation, but this equation is passing through the point 4 comma 7. So y is 7 and x is 4. So 2 times 4 to the power 3 by 2 minus 6 times 4 to the power half plus c. So this is 7, and when you use calculator over here, then this will be 16, and this will be 12 plus c. So you can use calculator, guys, here. Then this is 4, so c is 7 minus 4, which is 3. So finally our y will be 2 times x to the power 3 over 2 minus 6 times x to the power half, and c is 3. So we will get y equals this. Okay, now come to the next question. This question says, in each of parts a, b and c, the graph shown with the solid line has equation y equals fx. The graph is shown broken lines at the transformation of y equals fx. Okay, then state in terms of f the equation of the graph shown in the broken lines, in terms of f only, okay, not in this statement. So this and this, so these are mirror image of each other, right? So mirror image is written in terms of y equals f of minus x, and mirror image with respect to x-axis is y equals minus fx, like minus f of fx. So but b part is not that. Now b part is something else. This is fx, and this length, it has been multiplied by 2. Yeah, so it's simply, it's twice, because over here range is 1 to 3 and over here range is 2 to 6. See, fx was, this is 1 and this is 3, so 1 to 3, right? But this part, this is 2 to 6, right? So can you multiply by 2? So this is 2fx, so it means this is twice. Okay, range will be double. Yeah, that's it. So this is 2fx only. Okay, so range is multiplied by 2. Now next question is, C part, that says, state in terms of f the equation of the graph shown with broken lines. Okay, so first it is coming here, then going down, and everything is same, right? Yeah, so just 1 2 3 4 units left side, so minus 4, and 1 2 3 units down. So it is changing by minus 4 minus 3 as a column vector, but we have to write in terms of f. So y equals f of, if we apply this result, then f of x plus 4, and if you apply this result, it is changing in y, so just subtract 3. So this should be the answer. Expand in ascending power of a up to and including in terms of a cube. Okay, so 1 plus a to the power 5 is 5c0, 1 to the power 5 minus 0, and a to the power 0. Then 5c1, 1 to the power 5 minus 1, a to the power 1. 5c2, 1 to the power 5 minus 2, a to the power 2. 5c3, 1 to the power 5 minus 3, and a to the power 3. And we will not write because including the term in AQ. Ascending power up to and including the term AQ, only up to AQ. So 5c0 is 1, 1 to the power 5 is 1, a to the power 0 is 1. 5c1 is 5, 1 to the power 4 is 1, then this is a. 5c2 is 10, then 1, then a square. Then 5c3 is 10 into 1 into AQ, and it goes on. So I got 1 plus 5a plus 10a square, 10aq and all. Expand in ascending power of x up a up to and including. It is for 1 mark, it should be for 2 marks. By the way, hence expand 1 plus x squared to the power 5 in ascending power of x up to and including the term x cube. Okay, so this is a. If you check 1 plus a to the power 5, but 1 plus, instead of a we have x plus x squared. So just we can use this result, okay, and we have to use that result because hence it is given. So I can write 1 plus 5, and a is x plus x square, then 10 x plus x square whole square, then 10 x plus x square whole cube, and goes on. That's it. Now we have to write ascending power of x. Okay, so this is 1 plus 5x plus 5x square, and this is 10. Just expand first inside. So this will be x square plus just x plus x square whole square, right? You can write 2 times, and then you will get the result x square plus 2x cube plus x to the power 4. And here when you multiply, when you expand, then definitely you will get x cube and some more terms, but we are not interested on more terms because we have to write up to x cube only, right? Okay, so this is 1 plus 5x plus 5x square, 10x square, 20x cube, but 10 times x to the power 4 I'm not interested. I will not write because we have to write up to x cube, so just ignore that. Now 10x cube, and just write 3 dots. So 1 plus 5x square and 10x square, which is 15x square and 20x cube and 10x cube, which is 30x cube and dot dot dot. So 1 plus 5x, 15x square and 30x cube. So this is the answer. Now come to the next question. This says the diagram shows a cord going around a pulley and a pin. The pulley is modeled as a circle with the center O, radius 5. Thickness of the cord and the size of the point P can be neglected. The pin is situated 13 meter vertically below O. The points A, B are on the circumference of the circle such that AP, PP are tangents. The cord passes over over the major arc AB of the circle and under the pin such that the cord is taut. Okay, now find the length of the cord. So length of the cord will be this arc length plus this, okay. Now, so what are the informations we have? We have this. We can easily find this angle theta. We can easily find this angle, and then we can easily find this angle. Okay, so here we can apply sine theta. So if I apply sine theta, then opposite is 5 and hypotenuse is 13. So theta is sine inverse 5 over 13. My calculator should be in radian. It's already in radian. So shift sine inverse 5 over 13. So that is 0.395. 0.395 I can write. So this is 0.395 now. Okay, so here I will use this. This is 0.395. This is also 0.395. 0.395. So total will be 0.395 times 2. This will be 0.79. So that will be 0.79. But this is 90, this is 90. So sum of this and this should be 180, right? Pi. So if this is 0.79, then this will be like this angle, because sum of this and this is always 180 or pi. So I can get this is pi minus 0.79, right? Then this angle will be 2 pi minus 0.79. So first we can get pi minus 0.79, which is 2.35. So now this angle I have 2.35. So outer will be 2 pi minus 2.35, because angle made around the point is 2 pi. So now 2 times pi, that's 2 pi minus 2.35. 2 pi minus 2.35, which is 3.93. So this is 3.93. Okay, so this one and this one. So here we have 3.93, and this length, this angle is 0.79. By the way, we need to find this major arc length and this length. Just we have to add. I don't think this is a very difficult question. By the way, major arc length, like we need to find this arc length, then I have to consider this angle. So this arc length I'm considering L. So L equals r theta. So r is 5 and theta is this, okay, this one, which is 3.93. So 3.93 times 5. 3.93 times 5, which is 19.65. And I need to find this length PA. So PA I need to find. What can I apply? I can apply Pythagoras theorem also. So PA is root of this 13 is square and 5 is square difference. 13 is square and 5 is square. So root of 13 square minus 5 is square, which is 12. So this length is 12, then this will be 12. So length of the chord will be PA plus arc length L, then BP. So PA is 12, L already I got 19.65, and then again 12, right? So 12 plus 19.65, which is 43.65, right? It was 6 marks. It was easy problem. Now come to the next question, which is question number 6. Point P is moving along the curve is such that a way that x coordinate of P is increasing. X coordinate of P is increasing. So dx over dt increases at the constant rate of 2 units per minute. The equation of the curve is given to us. Y equals 5x minus 1 to the power half. Find the rate at which y coordinate is increasing. So guys, we know that dy over dt we need to find. So dy over dt can be written as dy over dx times dx over dt. So dx over dt is available, dy by dx we need to find. So just differentiate this with respect to x. So half will come here, then 5x minus 1 to the power half minus 1, then x coefficient is 5, which you have to write here. Now dy by dx is 5 over 2, 5x minus 1 to the power minus half. Okay, so finally dy over dt will be 5 over 2 times 5x minus 1 to the power minus half, and then dx over dt I will write 2. And we have to use x equals 1 because we need to find rate of change of y when x is 1. So 5 over 2, 5 times 1 minus 1 to the power minus half times 2. 2 and 2 you can cancel. Now 5 times 5 minus 1, that's 4. 4 to the power minus half, which is 5 over 2. Okay. Now B part, find the value of x when y coordinate is increasing at 5 over 8 units per minute. Okay. Find the value of x when y coordinate is increasing at 5 over 8. No problem. Dy over dt this time given 5 over 8. But dy over dt is dy over dx times dx over dt. So dy over dt is 5 over 8. dy by dx already we found 5 by 2, 5x minus 1 to the power minus half. 5 by 2, 5x minus 1 to the power minus half, and dx over dt is given in the main question, that is 2. So that is 2. Now we need to solve it. 2 and 2 we can cancel, this 5 and 5 we can cancel. So 1 over 8 equals 5x minus 1 to the power minus half. Then 1 over 8 equals 1 over 5x minus 1 to the power plus half. Then cross multiplication. Then 5x minus 1, 5x minus 1 to the power half equals 8. Now 5x minus 1, now square both sides. 2 and 2 cancel. 5x minus 1 is 64. 5x is 64 plus 1, which is 65. Now divide by 5 both sides. 5 and 5 cancel. X is equal to 13. Okay. So we got that. Now come to the next question that says tan theta over 1 plus cos theta and tan theta over 1 minus cos theta is this. Okay, that's great. Then we can take first tan common. Then 1 over 1 plus cos theta plus 1 over 1 minus cos theta. Now, you know this logic. So 1 minus cos theta is multiplied with 1 minus cos theta, plus this 1 plus cos theta will multiply to this one. And then divided by, you have to multiply these two brackets. 1 plus cos theta and 1 minus cos theta. So this tan theta you have to write sin theta over cos theta, and then times here numerator is 1 plus 1, that's 2, and minus cos plus cos cancel. So, and this is 1 plus cos, 1 minus cos. So you can write a plus b, a minus b, a square minus b square. So 1 square minus cos square theta. Sin theta into 2 over cos theta into 1 square is 1. So 1 minus cos square is sin square. So this is sin square theta. So 1 sin you can cancel. Now 2 over cos theta times sin theta. So 2 over sin theta times cos theta, or 2 over cos theta times sin theta, same. Now hence solve. Okay, tan over 1 plus cos, tan over 1 minus cos is 2 over sine cos. So we can write 2 over sine theta cos theta, and this is 6 over tan theta can be written as sine theta over cos theta. Okay, then this is 2 over sine theta cos theta, and this is 6 times this sine over cos will be cos over sine. Okay, now this sine and this sine you can cancel, so this is 2 over cos theta is 6 cos theta, so 2 equals 6 cos square theta. Cos you can multiply both sides. Cos square theta is 2 over 6, you can divide by 6, which is 1 over 3. Now cos theta is plus minus root 1 over 3. So cos theta is plus 1 over root 3, and cos theta is minus 1 over root 3. So theta is cos inverse 1 over root 3, and theta is cos inverse minus 1 over root 3. Now theta, and our question in terms of angle, so our calculator should be in terms of, our angle is terms of degree, so our calculator must be in degree. So I need to convert in degree. Now shift cos inverse 1 over root 3, which is 54.73. So I will write 54.7, and next is cos inverse minus 1 by root 3, which is 125.26. So I can write 125.3. So these two should be answered, and these two are valid because these two are lying between 0 to 180 degree. Now question is, the first term of the progression is sine square theta, and theta is given 0 to pi by 2. Second term of the progression is this. Given that the progression is geometric, then sum to infinity, no problem. So this is sine square theta, this is sine square theta, cos square theta, and goes on, but this is in GP, it's already given to us. So A is the first term, so A is sine square theta, R is the common ratio, so second term divided by first term, so got cancelled, cos square theta. So now we need to find sum to infinity. S infinity is A over 1 minus R. A is sine square theta over 1 minus cos square theta. But 1 minus cos square theta is sine square theta. So got cancelled, you will get 1. It is now given instead that the progression is arithmetic. Find the, no problem. So first term was sine square theta. Second term is sine square theta, cos square theta, but this is in AP this time. Find the common difference of the progression. So just take difference, that's it. Why it is for 3 marks? So common difference, sine square theta, cos square theta minus sine square theta, right? Just take sine square theta common, which is cos square theta minus 1. Now you can take minus common, then you can write 1 minus cos square theta. Then 1 minus cos square theta you can write sine square theta, which is minus sine to the power 4 theta. So it's a free marks if you have information about trigonometry. Find the sum of the first 16 terms when theta, and this is related to B, so it's for AP. Find the sum of first 16 terms when theta is pi over 3, no problem. Now Sn is n over 2, we know that, 2a plus n minus 1d. Now 16 over 2, 2a, a was sine square theta, so 2 sine square theta, and n is 16 minus 1, and d already we got minus sine to the power 4 theta, and this is s16 this time. Here I should convert 16. So 8 and the 2 times sine square theta, so 2 times sine square, and this is pi by 3 plus 15 times minus 1 times sine to the power 4 pi by 3. Now just use calculator over there. So 8 times 2 sine pi by 3 is root 3 by 2, so it's 3 by 4, and it's minus 15, and then 9 by 16. Okay, now I will use calculator. So this is 6 over 4 minus 15 times 9 over 16 and multiply by 8. So what I got minus 55.5, or you can say minus 111 over 2. Okay, question number 9, that says the function fx and gx available, express fx in the form of perfect square. So x square minus 4x plus 3, just use this. X minus x coefficient half, so x minus 2 whole square, and same minus 2 square plus 3, then x minus 2 whole square minus 1. Next is, it is given that f is 1 1. Okay, so you can understand this when you are able to draw the graph of this. So x is 2 units right and 1 unit down. Okay, and here you will get your curve something like that. Okay, so either this right portion is 1 1 or left portion is 1 1. 1 1 is either increasing or decreasing. Okay, so this is 2 and this is minus 1, so this coordinate is 2 comma minus 1. Now it is given that f is 1 1. State the smallest possible value of c. But here, you know, x is greater than c, x is greater than c. So of course they are talking about the right portion, so it means they are talking about this portion. So x is greater than 2, then only it is 1 1, right? So find the smallest possible value of c. So that should be 2, smallest possible value. Okay, now it is now given that c is 5. Find an expression of f inverse and state the domain of f inverse. So now we got here fx is x minus 2. What is fx? Fx is x minus 2 whole square minus 1, where x is greater than 2. X minus 1 whole square minus 1. X greater than c, but we already found c as 2. So fx is x minus 2 whole square minus 1 when x greater than 2. Where was c? Oh, x is greater than c, sorry. So x is greater than 5, because c is given this time 5. Okay, then y is x minus 2 whole square minus 1. Then y plus 1 is x minus 2 whole square. Then x minus 2 is plus minus root y plus 1. Then x is equal to 2 plus minus root y plus 1. Then here f inverse x, which is 2 plus root x plus 1, of f inverse x, 2 minus root x plus 1. But one of these we have to accept. So domain of fx, here domain of f is greater than 5. It means range of f inverse x is also same. So range of f inverse x is greater than 5. So 2 minus, if you do 2 minus, then it will be smaller than 2. So you should have this inverse, 2 plus root x plus 1. Okay, now state the domain of f inverse. Okay, state the domain of f inverse. It means we have to find range of f. So this is my f. Okay, when x is greater than 5, then can we write x minus 2? So 5 minus 2. Now x minus 2 whole square. 5 minus 2 is 3, so square is 9. But x minus 2 whole square minus 1, so 9 minus 1, 8. Now this is fx. Fx is greater than 8. When x is greater than 5, then fx is greater than 8. So range of fx is domain of f inverse x. So f inverse x is greater than 5, but for domain point of view, x should be greater than 8. So f inverse x is 2 plus root x plus 1, where domain is greater than 8. Find an expression for g of fx and state the range of g. Okay, so g of fx, so we have to write gx here. 1 over x plus 1, x greater than minus 1. 1 over x plus 1, x greater than minus 1. And fx already we found, x minus 2 whole square minus 1. And d part is totally different. D part we have to write in terms of domain will be in terms of c. Okay, 1 over x plus 1, x greater than minus 1, and f of x is x minus 2 whole square minus 1. What we have to write? G of fx, right? So 1 over gx plus 1, 1 over f, x became fx plus 1, and then 1 over fx, we have this x minus 2 whole square minus 1 plus 1, cancel. So 1 over x minus 2 whole square, I got g of fx, right? Okay, but now we have to understand about the domain of g of fx right now. So here for fx is greater than c, where c is constant. Okay, so here I'm going to consider x is greater than, no, x can be anything, just ignore that. Now when g of fx is this over here, you know, when we have substituted x as fx, then here also we have to substitute in the condition. So fx is greater than minus 1, so x minus 2 whole square is x minus 2 whole square minus 1 greater than minus 1. X minus 2 whole square is greater than 0, so it's fine. It's always valid, x belongs to any real number. But gx domain is greater than minus 1. Okay. So gx domain is x greater than minus 1. Now we have to find range of this. Okay, so now try to make x minus 2, so subtract 2, so x minus 2 is greater than minus 3. Now 1 over x minus 2 is smaller than minus 3, right? And it is a square. 1 minute. Can we square here? X minus 2 greater than minus 3. So if we do x minus 2 whole square Then x minus 2 whole square, if we do, then it will be, it's 1 over x minus 2 whole square, right? So obviously it is greater than 9, but it will be greater than 0. Okay, here x is greater than minus 1, right? And we have to find range for 1 over x minus 2, 1 over x minus 2 whole square. So just put minus 1 here. 1 over minus 1 minus 2 whole square, you will get 1 over 9. And x greater than minus 1, it means it will go to infinity. So 1 over infinity minus 2 whole square, which is 1 over infinity, which is 0. So what you will get? You will get 0 to 1 over 9. So finally you can say g of fx is 1 over x minus 2 whole square, and where gf is lies between 0 to 1 over 9. The coordinates of 2 points AB are available. Show the equation of perpendicular bisector. So this is A, minus 7, 3. This is B, 5, 11. Perpendicular bisector, it will go from the middle point. We need to find midpoint. Minus 7 plus 5, which is minus 2, over 2, which is minus 1. And 3 plus 11, which is 14 over 2, that is 7. And gradient of AB, I need to find y2 minus y1, 11 minus 3 over x2 minus x1. So 5 minus 7, 5 minus of minus 7. So 11 minus 3 is 8, and 5 plus 7 is 12. Now MAB is 2 by 3. Then we know the gradient of perpendicular line is minus 1 over gradient of AB. So minus 1 over 2 over 3 will be minus 3 over 2. So equation of line will be y minus y1 mx minus x1. So 2y minus 14 is minus 3x minus 3. Now take left side. This is 3x plus 2y equals minus 3 plus 14. 3x plus 2y equals 11. So 3x plus 2y equals 11. We got that? Now a circle passes through the point AB and its center lies on the line 12x minus. Okay, find the equation of the circle. So no problem at all. Sorry, this is not a good circle. Okay, no problem. This is A and this is B. AB, circle passes through AB and its center. Okay, how can I say this is the diameter? So again I have to draw one circle. So this is AB. Okay, center will be here. A circle passes through AB and center lies on the line. Okay, center lies on the line. Okay, so this line should pass through the center. 12x minus 5y. 12x minus 5y equals 70. At the center I don't know, so this is A comma B. But if I join to this middle point or to the perpendicular point, then it is join. You know, the perpendicular drop from center to the chord divides chord as half. So A is minus 7, 3. A minus 7, 3. And B 5, 11. b 511, and the midpoint is minus 7 plus 5 over 2, so minus 2 over 2 minus 1, and 3 plus 11 over 2, so that is 7. We have to find somehow AB value. So first center AB will lie on the line also, so 12A minus 5B is 70, and the gradient of AB or the perpendicular line, yeah, so AB this point AB will satisfy this line which we found earlier. So what was that? 3x plus 12y 2y11, 3x plus 2y11, instead of y we have to write b, because what is happening, please try to understand. This center lie on this line, and the center will lie on the perpendicular bisector also, so AB will satisfy this, AB will satisfy this line. Now simply we have to solve, but I think we can multiply by 4 this. So 4 times 3, that's 12, 4 times 2 8b, and 4 times 11 44. Now we have to do subtraction. 12 minus 12, that's 0, minus 5 and minus 8, minus 13b, and 70 minus 40, 70 minus 44, this is 26. So b is minus 2. 26 over minus 13, b will be minus 2. Now when b is minus 2, then we can get a as well, so just put b minus 2 over here to get a. So 12 times a minus 5b equals 70. So this is 12a plus 10 equals 70. 70 minus 10, that's 60. 60 over 12, that is 5. So I got a5. So now I have a, what we need to find? Equation of circle. So now I have a center which is a comma b, which is 5 comma minus 2, and suppose a point is this minus 7 comma 3. So can we find radius now by application of distance formula? Okay, so y2 minus x2 minus x1 whole square plus y2 minus y1 whole square. So difference of x whole square, difference of y whole square, addition. Then this is 5 minus of minus 7, so 5 plus 7 whole square minus 2 minus 3 square. So r will be 12 square and minus 5 whole square. When you solve, you will get 13. So r is 13. So now we have center and we have radius. So x minus x1 whole square, which is 5, y minus y1 whole square equals r square. So finally x minus 5 whole square, y plus 2 whole square, 169. Okay, now question 11, that says the diagram shows, okay, OB maximum, A is the maximum, so gradient will be 0, x coordinate of A is A, okay, A comma, and the curve has minimum point at B, okay, B comma 0, show that B equals 3A, B equals 3A. Show that B equals 3A. X coordinate of A minimum. So dy by dx should be 0 at A now. Yeah, we can do that. So y equals x cube minus 2bx square plus b square x. Dy over dx is 3x square minus 4bx plus b square Now dy by dx must be 0 at x is equal to a, because over here a is the maximum point, so gradient should be 0. So just put a in this. So 3a square minus 4ba plus b square equal to 0. So this is 3a square minus 4ab plus b square 0. So I got only one equation, but I did not get b equals 3a. Okay, minimum point at b comma 0. Can we factorize that? This is 3a square minus 4b plus b square. So this is 3a square and minus 3ab minus ab plus b square should be 0. Now 3a, if I take common, then this is a minus b. If I take b common, then again a minus b equal to 0. Now a minus b, then 3a minus b is 0. A minus b cannot be 0. If a minus b will be 0, then a equal to b, and a and b are different here, you can observe. So 3a minus b is 0, 3a equal to b. So b equals 3, that's fine. Show that the area of the shaded region between the line and the curve is this. So simply we need to find area. So we need to integrate upper part and lower part, and just we need to subtract. But I don't have, I think this is straight line curve, right? But I can subtract triangle area. But still I need point A. This is A comma, and y coordinate will be a cube minus 2b a square plus b square a, right? A cube minus 2b a square plus b square a. So this length is this one, and this length is a. By the way, I have to integrate, and I need to get this whole area. So I have to integrate this part 0 to a. So area of the shaded region is 0 to a, x cube minus 2b x square, x cube minus 2b x square, x cube minus 2b x square plus b square x. This minus area of the triangle, which is half base times height. Height is this, a cube minus 2b a square, a cube minus 2b a square plus b square a. Okay, now integrate this part. X to the power 4 over 4 minus 2b x cube over 3 plus b square x square by 2. X to the power 4 over 4 minus 2b x cube by 3 b square x square over 2. Now limit 0 to a minus a over 2, and this a cube minus 2b a square and b square a. Just put upper limit. A to the power 4 over 4 minus 2b a cube over 3 plus b square a square by 2 minus 8, just take a inside, minus a to the power 4 over 2 plus 2b a cube over 3. Now minus a over 2 times b square times a, which is minus b square a square over 2. Now use b equals 3a. Here it is given, like we found b equals 3, because we have to give answer in terms of only a to the power 4. I mean we don't require. So a to the power 4 over 4 minus 2 times b is 3a and a cube over 3, then b square is 9a squared times a square over 2 minus a to the power 5 over 2 plus 2 times 3a times a cube over 2 and minus, I think we can cancel this thing, so no need to write this part. Okay, actually b square a square over 2 and minus b square a square over 2 got cancelled, so we have only this one. So this is a to the power 4 over 4 minus 3 and 3 you can also cancel, minus 2 a to the power 4 minus a to the power 4 over 2, 2 and 2 cancel. This is 3a to the power 4. Now I will take a to the power 4 common, 1 over 4 minus 2 minus 1 over 2 plus 3, and then I will use calculator for that. 1 over 4 minus 2 minus 1 by 2 plus 3, which is 3 by 4. So a to the power 4, 3 by 4. So I got 3 by 4 a to the power 4. Okay, so they didn't ask this time volume question. Okay guys, so we did one practice paper, so I hope you revised also this P1 9709 AS Pure Maths. Okay, thank you very much. See you in the next class.